We always want to be able to check our work, and there are two common ways that we can check our work when we're simplifying rational expressions. One involves technology, one doesn't. You can do by hand. We're going to start with the one that doesn't use technology. The method that I'm going to go over first involves using a sample variable value to check to see if your original expression is equivalent to your final expression. Because the idea is when you simplify, what you start with is going to be equal to what you end up with. So the value for the first initial fraction should be the same as the last fraction you come up with. So what we do is we just choose a value for x and see if it really does come out to be the same. For instance, I could say x is equal to 3. And I'm going to calculate each of these using x equals 3 and see if I get the same result. So I'm going to put a 3 in to this first fraction. So I'm going to have 3 squared minus 3 times 3 minus 10 in my numerator. And then in my denominator, I'm going to have 3 times 3 squared plus 7 times 3 plus 2. So simplifying this fraction, work on the numerator and denominator separately. I'll square, 3 squared is 9, 3 times 3 is 9, so I have 9 minus 9, and then the minus 10 sticks around. In the denominator, 3 squared is 9 times 3 is 27, and then 7 times 3 is 21, plus 2. Now, adding and subtracting in the numerator and denominator, I get negative 10 on top, and then on the bottom, I get 27 plus 21 is 48 plus 2 is 50. Negative 10 over 50 will simplify to negative 1/5 because both top and bottom have a 10 in common. So in the original fraction, if I plug in x equals 3 in, I get negative 1/5. Let's see if we get the same thing in the simplified version. If I put a 3 in to the simplified version, I get 3 minus 5 over 3 times 3 plus 1. Simplifying the numerator, I get a negative 2. In the denominator, I get 9 plus 1, or 10. And when I simplify this fraction, 2 over 10 both have a 2 in common, so I'll take it out and I'll get negative 1/5. And you see how I get the same result in the original version as well as the simplified version. That means that these two expressions are equivalent. And so I did simplify correctly. Here's another example that we looked at earlier. In this example, we have two variables, and what we had started with was a minus b over b squared minus a squared, and we ended up with negative fraction 1 over a plus b. To see that these are equivalent, we need both a value for a and a value for b. I could use 3 for one of them and 4 for the other. It's really your choice. You could also use like 7, so if you want to use a different value, maybe a is 7, and I accidentally wrote a twice. We'll make b be 4. So if I have a is 7, b is 4. I recommend you don't use any variable as 0 or as 1 or as 2. There are some odd things that can happen when you calculate with 0, 1, and 2. So it's better to choose values that are not 0, 1, and 2 when you do this check. Now, let's go ahead and plug these values in. So my a is 7, my b is 4, so my first fraction has 7 minus 4 in the numerator, then 7 squared minus 4 squared. If we continue to simplify this fraction, I end up with 3 over 49 minus 16. 49 minus 16 is 33. 3 over 33 is 1/11. Now, let's see if we get the same thing on the other side. We have negative 1 over 7 plus 4. 7 plus 4 is 11, so I get negative 1/11. Now notice that's not the same, but I did make a mistake here. Does anybody see it? I got in a hurry and I threw this denominator in wrong. I should have had a 4 here and a 7 here, because remember b is 4, so I should have 4 squared, and 7 is a, so I should have had this a squared there, 7 squared. And so really I should have had in the denominator 16 minus 49, And 16 minus 49 is negative 33, and that simplifies to negative 11. So there's the corrected version. And you can see that they are the same value in the end. One thing to note, when you do simplify these or you check your answer, sometimes you can make a mistake in the check as well as in the original simplification process. If it was looking good and you were confident in how you simplified, it's always worth it to double check your check before you go back and try to rearrange your simplification. And in this case, that's what I did. I was pretty confident in my answer, and so I double checked my checked values. The other technique we can use to see if our simplified answer is correct is we can use technology or Desmos to actually graph what we started with and where we ended up and see if we get the same graph. Because remember, when we simplify, whatever we started with needs to be equal to what we end up with. So it should be identical in terms of the graphs. So I'm going to go ahead and graph a multiplication problem we dealt with earlier. Y equals w squared minus 9w, etc. But I can't use w, I need to use x squared in Desmos. So I'm going to say x squared minus 9x, oops, not 92, 9x. And then we're going to divide that by, our first denominator is x squared minus 9. Now we want to multiply that by, so I'm going to say times, the fraction x squared minus 3x, and that numerator is divided by x squared minus 7x minus 18. Now I had a lot there I was entering in, so let me just double check that I have the correct expression. So this was the original expression, x squared minus 9x over x squared minus 9 over our times x squared minus 3x, x squared minus 7x minus 18. Okay, that looks good. Now our simplified was much nicer. Y equals x squared all divided by, whoops, not the exponent by itself, the entire thing. So let me make sure I divide all of x squared by x plus 3 in parentheses times x plus 2 in parentheses. And as I entered that in, what you saw is that the graph kind of jumped around, but in the end, if I turn it off, you can see that my purple graph, which was the second simplified result, is actually overlapping the original green graph, which was where I started. That was my original multiplication problem. So these two graphs are exactly over top of each other. If I wanted to emphasize it, I can even change the style, and you can maybe see that the purple graph is right, if you don't see colors as well, the dotted graph is right over top of the green graph. So these are the same, or they represent the same value. One is simplified compared to the original.